This is the Large Hadron Collider. And these are two batches of protons. These protons are the basis of exploration for modern physics, costing about $1 billion each year. After these two groups of protons are emitted from a hydrogen tank and relieved of their electrons, these protons are sent into a linear accelerator, more commonly known as the LHC. This uses electromagnets to accelerate the proton's energy to 50 MeV. When the protons reach the end of the LHC, they enter the proton synchrotron booster, which, as the name suggests, boosts the energy of the protons to 1.4 GeV. This splits the usual group of protons into 4 groups where it is easier to boost the speed. At this point, linear acceleration is quite impractical due to the vast distances the pipe would have to cover. This is why the booster and every accelerator from here is circular in shape. After this booster, the protons enter the proton synchrotron. This accelerates the proton's energy to 25 GeV. The protons then enter the superproton synchrotron. At this stage the protons accelerate to an energy of 450 GeV and is the final stage before the protons enter the Large Hadron Collider. 27 kilometers in circumference. Made on the border between France and Switzerland. Once the protons enter this tube, they travel in different directions at an energy of 4 TeV, and once chosen to, they collide. This collision is when data is read from the collision and compiled by a computer bank. There are 4 main sensors: ALICE, ATLAS, CMS and LHC-1. ALICE stands for a Large Ion Collider experiment, which focuses on creating the extreme form of matter quark-gluon plasma. This supposedly was the state that all matter was in a fraction of a second after the Big Bang. This involves the extensive study of mainly hadrons, electrons, muons and photons produced in the collision of a proton with a lead nuclei or other heavy metal. ATLAS stands for a toroidal LHC apparatus. This aims to discover theorized particles such as the Higgs boson, which is the unification or supersymmetry of all of the key 4 forces at extreme temperatures and dark matter. CMS stands for compact muon solenoid, and aims to retrieve information about the forces that govern the universe, by searching for new particles and extra dimensions. And LHC-1 stands for Large Hadron Collider Beauty Experiment, and searches for B-hadron qualities such as asymmetries and charge conjugation and parity violations. In this video we will mainly focus on ATLAS. ATLAS, as mentioned before, aims to retrieve information about theorized particles such as the Higgs boson and dark matter. But on top of this, ATLAS aims to discover the answer to questions such as: why does matter have mass? What are the fundamental building blocks of nature? And how do they interact? Is there one theory that describes everything? ATLAS is the site of 46 million proton collisions at once, and with every particle being monitored for every piece of energy. These collisions are monitored by computers which register the data at an incredible 1 petabyte per second, scanning for data that could be considered interesting or data that may lead to the discovery of new particles. From the thesis of Eric Gromstad, it is somewhat clear that the Higgs boson's mass is